Okay, good afternoon, everyone. Can you hear me?
Good afternoon, sir.
Uh,
Yes, sir.
Good afternoon, everyone. So today we'll start the new organ, endocrine gland. Okay. So far we talk about we have already discussed about the hypothalamus, how it influences the anterior pituitary gland and posterior pituitary gland. We have discussed, and what are the hormones of anterior and posterior pituitary gland also, and what are their actions. Okay, in brief, we have discussed. Okay, so pituitary gland is master gland of the endocrine system because it will influence almost all body, or we can say virtually all the tissues of the body are influenced by the hormones of the pituitary gland. Okay, today we'll be discussing the organ, okay, which is influenced by pituitary hormone. Okay, that is thyroid gland. Okay, thyroid gland is influenced by the TSH. So you already know that TSH is thyroid stimulating hormone. Okay, it stimulates the thyroid gland. Okay, so thyroid gland is this topic is very big. Okay, we also know that nowadays there are so many problems regarding the thyroid gland. Thyroid insufficiency, sometimes too much secretion of the thyroid hormones are there. Okay, and I think you might be knowing some people who are suffering from this condition. Okay, too much thyroid hormones or too less. The thyroid hormone is too less. Okay, so both the conditions they are undesirable. Okay, so that pathological condition also we'll discuss. Let us first discuss what is thyroid gland. Okay, so it is an endocrine gland. It is located immediately below the larynx. Okay, immediately below the larynx. Here we know the larynx. Larynx, we can say that this is a voice box or it is a passage for the air also. Okay, so immediately below the larynx, on each side and anterior to the trachea. So on each side means on each sides of the trachea. Okay, starting on the trachea, and here also on the anterior part of the trachea also. So it is looking somewhat like an alphabet of H. Okay, H alphabet. It is the shape is somewhat similar to that of H alphabet. Okay, so it is located in the neck region. Okay, so this is its location, and this thyroid gland, it is producing two important hormones. Number one is thyroxine or T4. Okay, another one is triiodothyronine or T3. Okay, so thyroxine T4, it can also be called as tetraiodothyronine. Okay, or T3 is triiodothyronine. So these are the true thyroid hormones. Both of them, they are the thyroid hormones. Okay, their function is similar. Okay, so another hormone secreted by the thyroid gland is the calcitonin. Okay, calcitonin, it is important for calcium metabolism, but calcitonin will be discussing when we talk about the parathyroid gland, not the thyroid gland, because it is more, this calcitonin is more related to the parathyroid gland. Okay, so when we talk about the thyroid gland, we have to remember two important hormones, thyroxine and triiodothyronine. Okay, so what are their functions? This T3 and T4, their function is to increase the metabolic rate of the body. Okay, to increase the metabolic rate of the body. So let's say, suppose if there is complete lack of thyroid secretion, let's say there is no secretion of either T3 or T4. Okay, what will happen is that the basal metabolic rate, BMR, okay, basal metabolic rate, it can fall to 40 to 50% below normal. Okay, you already know that T3 and T4, their function is to increase the metabolic rate. But if there is complete lack, okay, the BMR will go down from 40 to 50% below normal. Okay, So on the other hand, when there is too much secretion of these thyroid hormones, T3 and T4, okay, the basal metabolic rate, BMR, it may increase from 60 to 100% above normal. So both conditions are undesirable pathological condition. Okay, they are undesirable. So the secretion of thyroxine and phytothyroid, it should be within the normal range. Okay. So as you know, as I've already told you, this thyroid secretion, T3 and T4 secretion, it is controlled primarily by TSH. Okay, TSH, you already know, thyroid stimulating hormone, which is produced by the anterior pituitary gland. Okay, so TSH is controlling even the growth of the thyroid gland. It is controlling the synthesis and secretion of T3 and T4. Okay, so as I told you, thyroid gland also secretes another hormone, calcitonin, an important hormone for calcium metabolism. Okay, so this calcitonin, as I've already told you, we'll be discussing in more detail under parathyroid gland. Okay, when we talk about the functions of parathyroid gland. Okay, now another important point is here. About 93% of the metabolically active thyroid hormones, okay, secreted by thyroid gland is thyroxine. Okay, so when thyroid gland is synthesizing or secreting the thyroid hormones, okay, 97% are thyroxine. Only 7% are triiodothyronine or T3. Okay, so more amount of T4 is released into the bloodstream if you compare with that of the T3. Okay, but here important point comes here. Okay, however, almost all the T4, okay, thyroxine is eventually converted to T3 in the tissues. So here this diagram you just see. Okay, so this T4 is, let's say, in the circulation 93%. Okay, T3 is only 7%. So both of them, they enter the target cell. Okay, but in the target cell, all of the T4, they will be converted into T3. So we can say that the active thyroid hormone inside the target cell is T3. Okay, not that T4, because almost all of that T4, they are converted into T3, and that will act on the genes of the cell. Okay. The functions of these two hormones, that means T3 and T4, are qualitatively same. Qualitatively same means what they are doing is similar. They will increase the metabolic rate, but they differ in rapidity and intensity of action. Okay, so this is their difference. Okay, T3 and T4, they differ in rapidity and intensity of their action. Okay, let's say which one is more potent. Okay, T3 is about 4 times as potent as thyroxine. Okay, so T3 is more potent regarding rapidity of its action or intensity of its action if we compare with that of the T4. Okay, 4 times as potent as the T4. Okay, but it is present in the blood in a much smaller quantity and persists for a much shorter time than thyroxine. So you know that in the blood, 93% belongs to T4, but only 7% are T3. Okay, that is why they are very much in smaller quantities in the blood and they persist for a much shorter time than the thyroxine. That means their plasma half-life is shorter than that of the T4. Actually, it is thyroid hormones. Most of them, they will bind to their plasma proteins. Okay, when we talk about the classification of, or what we say, transport of the hormones. Okay, in the beginning of the class. Okay, transport of the hormones. There, most of the thyroid hormones, they bind to their plasma proteins. That one also we'll discuss again afterwards. Okay. Now let's see the anatomical structure of the thyroid gland. Okay, so whenever we are going to study the physiology, okay, so up to some extent we have to know the anatomy also. Okay, otherwise we cannot do. Okay, but it will not be in detail. I think all this will be discussed in detail in, I think, anatomy class. Okay, let's say the thyroid gland is composed of a large number of closed follicles. Okay, so you can see, if you see the thyroid gland, okay, you get this type of structure. That means this is a follicle. Okay, here another follicle, here another follicles. Okay, so these are the follicles which are present in the thyroid gland. Okay, you see the diameter of these follicles ranges from 100 to 300 micrometers in diameter. Okay, and you see that these follicles, they are filled with the colloid. So this is the fluid-filled follicles, we can say. Okay, and as you can see from the diagram, it is lined by a single layer of cuboidal epithelial cells. Okay, this is 100 to 300 micrometer in diameter, and it is filled with a colloid and surrounded by a single layer of cuboidal epithelial cells. Okay. Now, what about the blood flow? Okay, the blood flow to the thyroid gland. The thyroid gland has a blood flow about 5 times the weight of the gland each minute. That means the blood supply to the thyroid gland is very high. Okay, every minute. Okay, within 1 minute. Okay, the blood flow which is flowing through the thyroid gland is 5 times the weight of the gland itself. Okay, that means the blood supply is very high. Okay, so the blood supply is as great as that of any other area of the body, with the possible exception of the adrenal cortex. Okay, so again, another important point here, the major constituent of the colloid. Okay, the colloid, let's see, this is the colloid and this is the cuboidal epithelial cells. Okay, you see that here, rough endoplasmic reticulum is here, Golgi apparatus is here. Okay, so this is the colloid part. Okay, you can see from here, this diagram is extended. Okay, here just imagine this is a single layer of the cuboidal epithelial cells having cell organelles such as rough endoplasmic reticulum and Golgi apparatus. Okay, and this is the colloid. So this is the fluid-filled lumen. Okay, now here we have to remember that what is this? Thyroglobulin. Okay, so inside the colloid, okay, thyroglobulin are there. This thyroglobulin, they are nothing but the glycoprotein composed of amino acids and, let's say, carbohydrates. Okay, these are the thyroglobulin. Okay, thyroglobulin protein molecule which are present inside the colloid. Okay, so the major constituents of this colloid is thyroglobulin. Okay, and this thyroglobulin, they are important for thyroid hormone synthesis, or in their structure or molecule itself, they will store the thyroid hormones T3 and T4. Okay, so as you can see from here, how thyroglobulin is synthesized. Okay, thyroglobulin, it is a glycoprotein, so protein has to be synthesized in the ribosomes of the rough endoplasmic reticulum by transcription and then translation. Okay, and then from the Golgi apparatus, vesicles will be formed, and by the process of, let's say, exocytosis, okay, it will enter the colloid, so that thyroglobulin will be available inside the colloid. Okay, so once the secretion, okay, this one though we will discuss afterwards. Okay, that is how thyroglobulin is synthesized and stored inside the colloid lumen of the follicle. Okay, now the next topic is iodide pump or iodide trapping. Okay, clear or not?
Yes, sir.
Yes, sir.
Audible,
Yes,
huh?
sir.
Okay, so we know very well
Yes,
that.
sir.
Okay, I think all of you, know very well that this iodine is very important, essential for our body. That means it is important for the synthesis of the thyroid hormones. Okay, So earlier during our childhood also, there were lots of this iodine deficiency. Okay, so people nowadays, so I think you have not observed any people who are having this enlarged, enlarged thyroid gland and all. Okay, but during my childhood, there are so many people. Okay, there were so many people who are having this enlarged thyroid gland, big ones were there. Okay, that was because of the deficiency of iodine. Okay, deficiency of iodine will lead to deficiency of thyroid hormones. Okay, so during my childhood, this iodine salt was not available. Okay, nowadays I think everywhere we can get this iodine salt. Okay, at home also we'll be using only mainly this iodine salt. Okay, because iodine is present there. Okay, so during my UG time, our nutrition teacher told us that, okay, this World Health Organization earlier, they want to incorporate this iodine in sweets. Okay, sweets, this common sweets, we all know, okay, sweets. But after that, they thought that these sweets, okay, they are also somewhat expensive. So many poor people, they cannot afford, okay, sweets also during those times. Okay, it was a luxury. So they have changed their mind to incorporate in the common salt. Okay, common salt, everybody can access to, will be having this, they can purchase the common salt. Okay, so that means iodine deficiency, it will be overcome by incorporating in the common salt. Okay, that is why nowadays we can say that iodine deficiency is very less. Whenever there is some thyroid problem, okay, usually it is not the problem of the deficiency of iodine. It will be something else. Okay, although there are so many problems regarding the thyroid gland, but usually this is not the problem of the iodine deficiency. Okay, so that is how they have incorporated this iodine in the common salt, so that everybody can get sufficient amount of this iodine. Okay, that I'm just telling you that the history of that, how they have incorporated in the common salt. Okay, now let's see iodide pump or iodide trapping. What is this? Okay, so as I told you, iodine is a part of T3 and T4. Okay, or we can say iodine is required for the formation of thyroid hormones, because iodine is a part of the thyroid hormones only. Okay, so iodides ingested orally are absorbed from the gastrointestinal tract into the blood. Okay, now you see that iodides we have ingested. Okay, usually mainly through the common salt we have taken. Okay, so because this iodine deficiency is very common, because many soil, okay, they will lack the iodine. That means the plants which are grown in those areas also, there will be deficiency of the iodine. So when we ingest the plant again we will not get sufficient amount of the iodine. Okay, then we can get, where we can get is that from the common salt. Okay, so we have ingested the iodide, the salt. Okay, that means their iodides are there. Okay, and as you all know, digestion will take place, or we can say reabsorption from the gastrointestinal tract will be there. Okay, so here you just see in this diagram. Now, after reabsorption from the gastrointestinal tract, okay, this iodide now it enters the bloodstream and it will reach the capillaries also. Okay, it will reach the capillaries, and this iodide will also be passing through the thyroid gland. Okay, so this is that is depicted here. Okay, so this is iodide. You can see this green in color. Okay, balls. These are the iodide molecules. Okay, which is passing through the capillary of the thyroid gland. Okay. Then normally most of them are rapidly excreted by the kidneys. Actually, the absorbed iodides, they will be, most of them, they will be excreted by the kidneys. But that thyroid gland, they are having the capability to trap or to reabsorb this iodide, okay, into the, let's say, the cuboidal epithelial cells, that single layer of the follicle, okay. So about 1/5 are selectively removed from the circulating blood from the cells of the thyroid gland. That means this can be trapped, this can pass through the cell membrane. Okay, actually today I forgot the stylus pen. So you just see here, this iodide will be trapped by these follicular cells. Okay, and they are then used for the synthesis of thyroid hormones. Okay, so in the next slide it will be clearer. Okay, so the first stage in the formation of thyroid hormones is the transport of iodides from the blood into the thyroid glandular cells and follicles. Okay, let us just say this diagram is opposite to the previous diagram. Okay, here this is the capillary. Okay, this is the capillary. Okay, and having blood, and this is the follicular cells, the cuboidal epithelial cells, and this is the colloid. Okay, you got my point or not? This is the capillary, cuboidal epithelial cell, and this is the colloid. Okay. Now let's say this iodide, which is present in the blood or in the capillary of the thyroid gland, now it enters the cuboidal epithelial cells by using sodium iodide importer. Okay. So we can say it will enter along with the sodium. Okay, you already know what is importer or import. Okay, two molecules, they are reabsorbed, they are transferred in the same direction. Okay, when we talk about the renal tubule. Okay, sodium and glucose, sodium and amino acids. Okay, those things we have already discussed. Just like that, here also a importer is present on the basal membrane of these follicular cells. Okay, so that iodide and sodium, they will be transported in the same direction. Okay, inside the follicular cells. So we can say this as iodide trapping. Okay, because this basal membrane, they have this specific ability. Okay, to pump iodide to the interior of the cell by using sodium iodide importer. Okay. So as I told you, this is done through the importer called sodium iodide importer. Okay. And the transport of iodide across the cell membrane is driven by the electrochemical gradient of sodium. So you already know all these things. This is secondary active transport system, but which is caused by the primary active transport system. Those things you already know. Sodium potassium pump. Sodium will be pumped out of the cell. Okay, those things I'll not repeat. Okay, in a normal gland, the iodide pump concentrates the iodide to about 30 times its concentration in the blood. That means because of this pump, okay, the concentration of iodine inside the cell can be as high as 30 times that of its concentration in the blood. Okay. So here we can say that concentration of iodide is very much higher as compared to that of the blood. That means this cell is having that special ability to trap iodide. Okay. So when the thyroid gland becomes maximally active, this concentration ratio can rise to as high as 350 times. Okay, so under normal condition, it may be 30 times more than that of the blood. Okay, but when the thyroid gland is having maximal activity, you can say, okay, it may still rise to 250 times. That means concentrating ability of the thyroid gland for iodine is very, very high. Okay. The rate of iodide trapping by the thyroid gland is influenced by several factors, the most important being the concentration of TSH. Okay, now, again, the important function of TSH comes here. It means TSH can increase the concentrating ability of the follicular cells for iodide. Okay, TSH is very important. As I told you, it is not only important for the growth of the thyroid gland. It is important for the trapping of the iodine. Okay, and even during the synthesis of thyroid gland, thyroid hormones, TSH is important. Okay, TSH stimulates the activity of iodide pump in the thyroid cells. Okay, so it will activate the iodide pump. Okay, this is important. Okay, now this is iodide trapping. Okay. Next is the synthesis of the thyroid hormones. How thyroid hormones are synthesized? Number one, formation and secretion of thyroglobulin by thyroid cells. Okay, so thyroglobulin, it is a glycoprotein. It is important for thyroid hormone synthesis. Okay, let's see. Okay, the thyroid cells are typical protein secreting glandular cells. So this is just a repetition of the previous slide. Okay, how thyroglobulin is synthesized, you already know. Inside the ribosomes of the rough endoplasmic reticulum, and they are passed on to the Golgi apparatus. And from the Golgi apparatus, a vesicles will pinch off, which are containing this thyroglobulin. Okay, and then they will be, extruded into the colloid of the follicle. Okay, so these are the thyroglobulin. Okay, that we have already discussed. So another important point, okay, even for your exam is that each molecule of thyroglobulin contains about 70 tyrosine amino acids. Okay, let's say this is a single thyroglobulin molecule. It contains around 70 tyrosine amino acids. So when we discuss about the classification of hormones also, I think you remember amino acid derived or tyrosine derived hormones. Those are thyroid hormones, dopamine, all those things we have discussed. Okay, so these are the tyrosine or amino acid tyrosine derived hormones. That means T3 and T4. They are tyrosine derived hormones. Okay, so a single molecule of thyroglobulin may contain around 70 number of tyrosine amino acids. Okay, so now you know how thyroglobulin is synthesized and secreted into the colloid. Okay, the second point. Okay, oxidation of iodide ion. Okay, so iodide, it is reabsorbed, okay, from the bloodstream into the follicular cells by Shimporter, we have already discussed. Okay, but this iodide ion, it has to be oxidized. Okay, it has to be in the oxidized form of iodine for the formation of thyroid glands, so thyroid hormones. Okay, then the iodide form, okay, it will not form, it cannot form the thyroid hormones. Okay, now when it becomes oxidized form of iodine, it is capable of combining directly with the amino acid tyrosine, which is present inside the thyroglobulin. Okay, to form thyroid hormones. Okay, this oxidation of iodine is promoted by the enzyme peroxidase. So let's see. Okay, so this is the blood. Okay, this is the bloodstream, and iodide is entering the follicular cells. Okay, the follicular cells. That you know, that single layer of the follicular cells. This is iodide, and then through the pendrin channel. Okay, it enters the colon. Okay, here at this membrane. Okay, apical membrane, especially on this apical membrane, an enzyme known as peroxidase, they are present here. Okay, and then it will convert iodide into oxidized form of iodine. Now this is the oxidized form of iodine. Then it can bind with tyrosine inside the thyroglobulin to form thyroid hormones. Okay, this iodide form, okay, unoxidized form, it cannot combine with the tyrosine in the thyroglobulin, but this will be converted by peroxidase enzyme, okay, into oxidized form of iodine. Then the oxidized form of iodine, then it can bind with tyrosine in the thyroglobulin to form thyroid hormones, either T3 or T4. Okay, thus providing the oxidized iodine at exactly the point in the cell where the thyroglobulin molecules issue forth from the Golgi apparatus and through the membrane and into the stored thyroid gland colloid. That means what it says is that when the iodine is passing through this membrane, okay, just near to this area, peroxidase enzyme will be there, so that it can convert iodine into oxidized form of the iodine. Okay. Now you see when the peroxidase system is blocked or when it is hereditarily absent from the cells, the rate of formation of thyroid hormones falls to zero. Suppose due to some reason the peroxidase is deficient, okay, it may be due to heredity, okay, or it may be some other reason. That means iodide form, they cannot be oxidized, okay. So because of that, formation of thyroid hormones will also be zero, okay. Now that is the second step for the formation of thyroid hormone. It is oxidation of iodide ion. The first one was formation and secretion of thyroglobulin. The second one is the oxidation of the iodide ion. Now the third step is organification of thyroglobulin. What is organification of thyroglobulin? Okay. The binding of iodine, oxidized form of iodine with thyroglobulin molecule is called organification of the thyroglobulin. It means iodine will bind with tyrosine, amino acids in that thyroglobulin. Let's see this diagram again. Iodine is transported into the cell, okay, and here it passed through this channel, membrane channel, and immediately after it has passed into the colloid, okay. Oxidation takes place. Iodine is converted into oxidized form of iodine by peroxidase. Just now we have discussed. Okay. Now this is the oxidized form of the iodine. Okay. And at the same time, here you see thyroglobulin. This protein molecule, glycoprotein molecule, is also released. Okay. From the endoplasmic reticulum, passing through the Golgi apparatus, and then by the process of exocytosis. Okay. It is now released into the colloid. Okay, then this thyroglobulin will combine with this oxidized form of what? Iodine. Okay, so this combination is known as organification of the thyroglobulin. Actually, this iodine, it will combine with the tyrosine, which is present in the thyroglobulin. Okay, so we can say here iodination takes place. Iodination of the thyroglobulin. That is known as organification of the thyroglobulin. Okay. So in the thyroid, oxidized iodine even in the molecular form will bind directly but very slowly with the amino acid tyrosine. Okay. So suppose this iodination can take place, okay, without any help of the enzyme. But the process, okay, this organification, the process will be too low. Okay. The rate will be very low, okay, so that will not sustain life. So because of that, there is presence of iodinase enzyme that causes the process to occur within seconds or minutes. Okay, now let's see this diagram very clearly again. I'll repeat once again. Okay, one thing we have to remember is that here from this area, thyroglobulin, it is entering the colloid. Okay. And from the bloodstream, iodine is entering this area, and oxidation takes place. And oxidized form of iodine now they are inside the colloid. Okay, so these are the oxidized form of the colloid, oxidized form of the iodine. Okay, okay, and this iodine now they will bind with the tyrosine inside the thyroglobulin. Okay, thyroglobulin they contain the amino acid tyrosine. Okay. Okay, and this combination is what we say increased or promoted by the iodinase enzyme. Okay, if there is no presence of iodinase, okay, the rate of combination, the binding will be too slow. Okay, and that will not be sufficient. Okay, to maintain normal metabolic rate. Okay, so here let's see iodine are there, then they are combining with the you have to remember that tyrosine here. Tyrosine inside the thyroglobulin molecule. Okay. Therefore, almost as rapidly as a thyroglobulin molecule is released from the body or task, or as it is secreted through the apical membrane into the follicle, iodine binds with about 1/6 of the tyrosine amino acids within the thyroglobulin molecule. So immediately when this thyroglobulin enters here and iodine enters here, okay, around 1/6 of the amino acid within that thyroglobulin, they will be in combination with the iodine. Okay, here they are there. Now let's see, okay, how this combination is there. So here you can see the free iodine, they are there in the colloid, okay, which are not bound to the tyrosine, okay. But what is the first step, okay, for the formation of the thyroid hormone? Let's see this oxidized form of one molecule of oxidized form of iodine combines with tyrosine with the help of iodinase. What it will form is monoiodotyrosine. Mono means one. Okay, it is having one molecule of the iodine here. You can see. Let's say this is the tyrosine. This is tyrosine, and this ball-like structure is the iodine. Okay, so it binds to the tyrosine. Or this we can say it is the monoiodotyrosine. Okay, in the second step, another iodine combines with monoiodotyrosine and it will form diiodotyrosine. Let's say now this is the diiodotyrosine. Di means two. Okay, two molecules of iodine, diiodotyrosine are there. Okay, and this monoiodotyrosine and diiodotyrosine, they are not yet thyroid hormones. Okay, they are not yet thyroid hormones, but still another combination is required. So in the third step, one monoiodotyrosine and one diiodotyrosine, they combine and they form the T3. Okay, suppose these two are combined, what they will form is here T3. Okay, here you can see 1, 2, 3, three molecules of iodine is there. Here another T3 is there. Okay, so to form T3, this is required. This reaction is required. For the formation of T4, okay, two diiodotyrosine come together and form the T4. Okay, these are the T4. Okay, this is how thyroid hormones are synthesized and stored inside the thyroglobulin, inside the colloid of the follicle. Okay, now storage, as I already told you, T3 and T4, they are stored within the thyroglobulin in large amounts. After synthesis of the thyroid hormones has run its course, each thyroglobulin molecule contains up to 30 thyroxine molecules and a few triiodotyrosine molecules. Okay, suppose there is the formation of thyroid hormone is complete. Okay, it means a single thyroglobulin may contain up to 30 thyroxine molecule. Okay, and a few T3. Okay. So in this form, the thyroid hormones are stored in the follicles in amount sufficient to supply the body with its normal requirement of thyroid hormones for 2 to 3 months. That means thyroid hormones, they can be stored for a long time. That means suppose there is stoppage of the synthesis of thyroid hormones. Okay, it can still supply the body for the next 2 to 3 months if there is no new synthesis of the thyroid hormones also. That means their storage capacity is very, very high. Okay. Therefore, when synthesis of thyroid hormone ceases, the physiologic effects of deficiency are not observed for several months. Okay, because storage capacity is high. Now the synthesis we have finished. Okay, up to this, the synthesis we have finished. Now how they are secreted. How thyroid hormones are secreted. Okay, so now they are inside the colloid. That means inside the thyroglobulin. Okay, located in the colloid. Okay, thyroglobulin itself is not released into the circulating blood in measurable amounts. Okay, actually this thyroglobulin, they will not be that protein. Okay, protein molecule, they will not be secreted into the bloodstream to a great extent. Okay, instead thyroxine and triiodotyrosine must first be cleaved from the thyroglobulin molecule. That means they should get detached from the thyroglobulin molecule before they enter the bloodstream. Then these free hormones are released into the bloodstream. Okay, let's see how this is taking place. Okay, Number one, the apical surface of the thyroid cells send out pseudopod extension that enclose around a small portion of the colloid to form pinocytic vesicles that enter the apex of the thyroid cells. So we'll just see the pseudopod is formed. Okay, pseudopod is formed. That means this will be pinched. This is pinched off. Okay, that vessel you already know how it is formed. Okay, so this is pinched off from the colloid. Okay, so this is containing T3 and T4. Okay, then thyroglobulin colloid is endocytosed by the process of endocytosis. Okay, this is pinched off. Okay, it will get detached from here. Okay, and combined with the lysosome. So once inside the follicular cells, so this is the inside of the follicular cells, it will come in contact with lysosomes. Lysosomes, you know that. Okay, these lysosomes, they are having large number of enzymes. Okay, the lysosomes in the cytoplasm immediately fuse with these vesicles to form digestive vesicles containing digestive enzymes from the lysosomes mixed with the colloid. That means it will fuse with the lysosomes and it will be internalized. Okay, T3 and T4 will be internalized so that there can be digestion of these molecules. Because here you have to remember that thyroglobulin, they are still there along with the T3 and T4. Okay, so their digestion, thyroglobulin digestion is essential. Number 3, multiple proteinases. That means these are enzymes. Among the enzymes digest the thyroglobulin molecules and release thyroxine and T3 in free form. That means digestion takes place here. Digestion of the thyroglobulin takes place so that T4 and T3 now they are free from the thyroglobulin so that they can enter the bloodstream now. Okay. Then this then diffuse through the base of the thyroid cells into the surrounding capillaries. Thus, the thyroid hormones are released into the bloodstream. Okay, T3 and T4 now they enter the bloodstream. But as I told you, most of them they will bind to the plasma protein only because thyroid hormones they are not water soluble. Okay, so most of them they will bind to their plasma proteins. Okay, so about 3/4 of the iodinated tyrosine, okay, in the thyroglobulin never become the thyroid hormones. So we have to remember that this monoiodotyrosine or diiodotyrosine, okay, and even this free iodine, okay, they never become around 3/4 of them. They never become T3 and T4, okay. But remains monoiodotyrosine and diiodotyrosine. So they remain as such, monoiodotyrosine, diiodotyrosine. Okay. During the digestion of the thyroglobulin molecules to cause release of the thyroxine and tridothyronines, these iodinated tyrosine are also freed from the thyroglobulin molecules. Okay. So you have to remember that this vesicle is not containing T3 and T4. Here it is showing the diagram of T3 and T4 only. Here also you have to remember that, let's say T1 and T2, monoiodotyrosine and diiodotyrosine, they are also present here. Okay, they are also present here when it was digested by the enzymes of the lysosomes. They are also free from the thyroglobulin. Okay, the thyroglobulin, and here just imagine that here T1 and T2 they are also here. They are not released into the bloodstream. Instead, they are going back to the colloid. Okay, for further use. Okay, for the synthesis of another thyroid hormones. Okay, however, they are not secreted into the blood. Instead, their iodine is cleared from them by the iodinase enzyme that makes it virtually all the iodine available again for recycling within the gland for forming additional thyroid hormones. Okay, so their iodines they will be again available for the synthesis of the thyroid hormones inside the colloid, or that is inside the thyroglobulin. Okay, so this is important. This is performed by the iodinase enzyme. Okay, opposite to that of iodinase enzyme. Okay, it gets, we can say, it detaches the iodine from the monoiodotyrosine and diiodotyrosine. Okay, in the congenital absence of this enzyme, the iodinase enzyme, many persons become iodine deficient because of failure of this recycling process. Okay, so there is failure of the detachment of iodine from monoiodotyrosine and diiodotyrosine. Okay, if there is deficiency of the iodinase enzyme. So a person may suffer from the deficiency of the iodine in this condition. Okay, so about 93% you already know thyroid hormones, they are released into the T4. They are T4 into the bloodstream, and 7% is only thyroid or T3. However, during the ensuing days, about one half of the thyroxine is slowly deoxygenated to form the additional T4, T3. That you already know, that I've already told you. Most of the T4, they are eventually converted into the T3 inside the target cell. Okay? Or we can simply say that the active thyroid hormones is the T3. Okay? Okay, this is for today. Thank you. May leave now.
Thank you,
Thank you,
sir.
sir.